Welcome back, space explorers, to Universe Intelligence. In our last video, we unveiled many of the sun's secrets, but this star still has plenty of stories to tell. Get ready to discover extreme solar phenomena, daring space missions, and mysteries that leave scientists scratching their heads. Today, we're diving into the sun's more turbulent and mysterious side. We'll talk about sunspots, those dark and cooler regions on the solar surface, the explosive bursts of energy known as solar flares, and the sun's corona, an outer atmosphere that's hotter than the surface itself. We'll also take you on board NASA's Parker Solar Probe mission, which is literally touching the sun to uncover its deepest secrets. Sunspots are dark, cooler areas on the sun's surface. But don't let their calm appearance fool you. They're zones of intense magnetic activity. The sun's magnetic field is like a tangled mess of invisible rubber bands, and sunspots are where these bands twist and snap, releasing enormous amounts of energy. Solar flares are like giant cosmic fireworks displays. They're powerful bursts of radiation that can release the equivalent energy of millions of atomic bombs. These explosions are caused by the sudden release of energy stored in the sun's magnetic field. Solar flares can have a significant impact on Earth. They can cause the beautiful aurora borealis in Australis, but also disrupt radio communications, damage satellites, and even threaten power grids. That's why scientists constantly monitor solar activity to predict and mitigate the effects of these extreme events. The solar corona is one of the sun's most intriguing mysteries. It's the outermost layer of our star's atmosphere, an aura of extremely hot plasma that extends millions of kilometers into space. But here's the paradox. The corona is much hotter than the sun's surface. While the surface hovers around 5,800 Kelvin, the corona reaches temperatures of 1 to 3 million Kelvin. Scientists are still trying to figure out how this is possible. The sun's magnetic field is thought to play a crucial role in this heating process, but the details are still under intense investigation. The sun isn't just a simple ball of fire. It's a complex structure with distinct layers, each with unique properties. At the center lies the core, the sun's powerhouse, where nuclear fusion generates solar energy. Above the core is the radiative zone, where energy travels outward as radiation. This zone is so dense that photons take thousands of years to pass through it. Next is the convective zone, where energy is transported by churning motions of plasma. Imagine giant bubbles of hot plasma rising to the surface, cooling, and then sinking back down, like boiling water in a pot. These convective motions are responsible for the granulation we see on the photosphere, the sun's visible surface. The photosphere is where most of the light we see comes from. It's also where sunspots form, cooler, darker regions caused by intense magnetic fields. Above the photosphere is the chromosphere, a thin, transparent layer of the solar atmosphere. Despite its thinness, the chromosphere is a dynamic place with jets of hot plasma called spicules rising like dancing flames. It's also where spectacular solar prominences occur, massive arches of plasma that extend hundreds of thousands of kilometers into space. Finally, there's the corona, the sun's outer atmosphere, incredibly hot and only visible during total solar eclipses. The movie Knowing painted a terrifying picture of a future where a massive solar flare incinerates Earth. While this scenario is highly unlikely, it reminds us of the sun's destructive power and our vulnerability to extreme cosmic events. The most powerful solar flares, called superflares, can indeed release enormous amounts of energy and radiation. If a strong enough superflare were to hit Earth, it could cause significant damage to power grids, satellites, and communications. It could also endanger astronauts in space and damage the ozone layer, increasing our exposure to harmful ultraviolet radiation. However, it's important to emphasize that the probability of a mass extinction event caused by a solar flare is extremely low. Earth is protected by its magnetic field and atmosphere, which shield us from most harmful solar radiation. Additionally, superflares are rare events, and even if they occurred, their direction and intensity would be critical factors in determining their impact on Earth. Nevertheless, the scenario of a catastrophic solar flare reminds us of the importance of studying and understanding the sun, not only for its beauty and its role in our solar system, but also for the potential dangers it could pose. To unlock the secrets of the solar corona and solar wind, NASA launched the Parker Solar Probe in 2018. This spacecraft was designed to withstand extreme heat and get closer to the sun than any other mission before. The Parker Solar Probe is literally touching the sun, flying through the corona and gathering precious data on its composition, temperature, and magnetic fields. This information will help us better understand the processes happening in the solar atmosphere and predict space weather events that can affect Earth. Wow, that was a wild ride through the sun's fiery domain. Did you learn something new? Were you surprised by any of the facts or theories we explored? Let us know in the comments below. We love hearing from our universe intelligence community. What questions do you have about the sun? Are there any other celestial wonders you'd like us to investigate? Drop your suggestions in the comments, and who knows, your idea might just become our next video. And if you haven't already, be sure to hit that subscribe button and join our cosmic crew. We're on a mission to explore the universe's greatest mysteries, and we want you to be a part of it. Together, we can unlock the secrets of the cosmos and have a blast doing it. So what are you waiting for? Let's keep the conversation going and continue our journey through the stars. Thanks for watching, and until next time, stay curious, stay adventurous, and keep exploring.